Today we are going to learn about types of diffraction. Crystallography is a discipline of study that examines the geometric structure of crystal lattices as well as the arrangement and bonding of atoms in crystalline materials. In the past, the optical characteristics of crystals were useful for identify compounds in chemistry and mining. Bragg's law: when radiation with a wavelength similar to atomic spacings is dispersed specularly, reflected like a mirror, by the atoms of a crystalline system and experiences constructive interference, Bragg diffraction results. In a crystalline material, their waves are dispersed from lattice planes that are d layers apart from one another. The scattered waves maintain phase when they constructively interfere. The wavelength, the glancing angle, optics, and the grating constant d of the crystal are connected by the relation lambda equals to 2d sin theta. Bragg's diffraction: when two beams of the same wavelength and phase approach a crystalline solid, two distinct atoms within it disperse the two beams. The bottom beam travels an additional 2d in length. When its length is equal to an integer multiple of the radiation's wavelength, constructive interference happens. Our focus of study in crystals diffraction are three, which are electron diffraction, neutron diffraction, and lastly, X-ray crystallography. Firstly is electron diffraction. Electron diffraction happen when the electron beam is projected onto a specimen. Its crystal lattice acts as a diffraction grating, scattering the electrons in a predictable manner, and resulting in a diffraction pattern. Electron diffraction patterns are used to obtain quantitative data, including phase identification, orientation relationship, and crystal defects in materials, usually performed in transmission electron microscope and scanning electron microscope. Shown is schematic representation of diffraction electron when it hits the sample and how the electron are diffract. What is neutron diffraction? Neutron scattering is applied to determine atomic or magnetic structure of material. Neutron used to scatter off the nuclei. Sample examined in beam of thermal, hot or cold neutron to obtain diffraction pattern that can provide information about the structure. In order to get proper of wavelength neutron, it can be produced in a nuclear reactor. This is schematic representation of diffraction neutron when it hits the target. X-ray crystallography. To determine the molecular and atomic structure of a crystal using electromagnetic radiation, X-rays. The crystal causes X-rays to diffract in specific direction. Bragg's law is useful for measuring wavelengths and for determining the lattice spacing of crystals. The clouds of electrons are at the same scale as the X-ray radiation wavelength. X-rays are used in this method. This implies that the electrons of the atoms in the crystal deflect and scatter the radiation. When the diffraction occurs, the diffracted X-rays form a pattern that exposes structural orientation of each atom in a given compound.
This is schematic represents how X-ray crystallography works.
That is all for our presentation. Thank you for your time.